Hi everyone, welcome. So thanks for joining us in person and everyone online for the first of our series of 4 textile talks taking place this fall and winter 2025 and going into 2026. These sessions are presented by our Fibre platform and Kite Creates, and my name's Helen Weston, and I'm part of the Kite Creates team and the Fibre team. If this is your first event with us, thanks for finding and joining us in the basement. And if you haven't already, help yourselves to tea and coffee and snacks and stay with us after the talk for some networking time. For those who are new to us, a little bit about Fibre and Kite Creates. So Fibre is first of its kind academic research platform in the field of textile-based wearable technologies, operating here at the Kite Research Institute. Its mission is to make care accessible to people through technology by designing and integrating smart textiles across the healthcare system. Kite Creates is building bridges between innovators in healthcare and creative industries with an aim to merge these and create human-centered solutions for complex accessibility needs. So we hope you'll be able to join us for all 4 events in this series. Each is a standalone talk, but they are intended to build on each other so that by the end of the series, you have a foundational understanding of textiles and material science. So, I'm delighted to introduce our speaker, who will be taking you through this fantastic subject. So Dr. Saiful Hoque is a textile engineer, material researcher, whose work bridges fibre and polymer science, textile manufacturing, sustainability, and smart technologies. His research focuses on material performance, degradation, and the development of textile-based sensors and actuators for healthcare and rehabilitation. He has authored 25 peer-reviewed articles, 2 book chapters, and 18 conference abstracts, and has been actively contributing to securing national and international grants as both principal investigator and collaborator, leveraging his expertise in smart textiles and performance materials. Currently, Saiful is a postdoctoral fellow at the University of Toronto's Institute of Biomedical Engineering and here at Kite. In addition to his research, Saiful serves as Vice President of the Institute of Textile Science, ITS, Canada, where he supports knowledge and exchange and innovation within the textile community. So welcome, Saiful, and delighted that you're giving these talks for us.
Good morning, everyone, and thank you so much for being here. As I start, I would like to start by thanking Helen, of course, Garrick, who is work at Kite Create as well, and the whole Kite Create team for arranging this wonderful series of events. And I'm really honored to be here today, and hopefully we're going to have a good discussion session today. So I would like to start with checking in what I call the animal mode scale. So based on this animal mode scale, you can be very bold. You start to win the day. You can be like a turtle, easy, just going into the afternoon. You can be playful. So personally, I am feeling between 5 and 9. I'm curious and also energized and very ready to share and learn from all of you. So I'm going to ask the question based on this scale. How are you feeling today? Any number? 1, 2, 5, nice. Wow. 2, a lot of numbers. Thank you so much. So I'm really happy that all of you, in whichever scale you are, all of you are here and bringing your energy. Thank you so much. So as I start, I would like to start by the land acknowledgement. We wish to acknowledge this land on which Kite, Toronto Rehabilitation Institute, University Health Network operates. For thousands of years, it has been the traditional land of Huron-Wendat, the Seneca, and the Mississaugas of the Credit. Today, this meeting place is still the home to many indigenous people from across Turtle Island, and we are grateful to have the opportunity to work on this land. I would also like to do some access check because here at Kite, we understand access to be a shared responsibility, and it should be between everyone in this space. So I'm going to ask, is there anything about this space that could be the display or the sound or the speaking speed that we should address now? I will give few seconds. Or if there is anything comes up during the session, please feel free to let us know, or the Kite Create teams here will try our best to address if there is anything else. Okay, that may be for the next event. So we need a window for the room. Yeah, thank you so much. I would like to talk a little bit about what could be the session outcome. So by the end of this session, as Helen was mentioning, we're going to have 4 series of lecture session or the workshop. So at the end of this session, I believe you should have an understanding of the scope of this whole lecture series. So in next few slides, particularly slides from 7 to 13, I'm going to talk about the presence of textiles in everywhere, and I'm going to include what I'm going to explain in different sessions. Also, I hope you'll be able to recognize the omnipresence of textiles. At the same time, at the end of this session, I hope you will have some understanding on some basics of textile fibers and yarns, and you'll be able to relate the properties of fibers and yarns in the textile performance. So as I was mentioning, the presence of textile is actually everywhere. The chair you are sitting might have some textile inside. Also, if I go from our regular clothing to our home furnishing, industry application, medical uses, here we are in a medical facility, we have a lot of textile application, transportation, and space exploration. So I'll go one by one. Think about when we get up early in the morning. We are surrounded by textiles. Our mattress, our bed sheet, our pillowcase. If we talk about the curtain, most of the things in the bedroom is manufactured from textile fibers and yarns. I'll just give some example which is pertaining to my research as well. If I consider the bed sheet or mattress, one of the important things when you go to bed, we want to have a very comfortable sleep. At the same time, I would like to stress that right now the textile is going through a paradigm shift where you can see the textile not only as an aesthetic product, but also as a functional product. Let's give an example about sleep apnea. Here at Kite, I work in SleepDB lab, where we extensively work, not only me, I have some of my colleagues here, we extensively work on sleep apnea. And based on the literature, 30% of the global population is suffering from sleep apnea. They have been diagnosed, but the people who have not been diagnosed, among them 80% are at the risk of sleep apnea. Why a lot of people are not going for the diagnosis? One of the barriers is all the sleep tests, the way of diagnosis, you have to sleep into a lab or a sleep clinic, which is a barrier because we go for a clinic, go for a lab visit for 1 or 2 hours, but we don't want to spend our whole night, right? So right now, our mattress or our t-shirt is turning into a sleep monitoring device. You can have respiration band, you can have ECG monitoring, you can have your posture monitoring, all in your bed sheet, in mattress, or your t-shirt. So the textile is really going to functionalize this test. But not about talking about the sleep apnea. At the same time, you also need something which meet your aesthetic purpose. So in our bed sheet, we want it to be crease resistance or wrinkle resistance. That's another property comes up. And according to research, it says that if your bed sheet or pillowcase is unwashed for more than a week, in just 1 square inch, it can have more than 17,000 bacterial colonies. So getting your bed sheet or sleeper with an antimicrobial finish is just not an aesthetic purpose. It's becoming a necessity because of the danger coming up. So when you are developing a textile, you need to consider the chemistry of the fibers, consider of the chemistry of the yarn, and at the same time, what are the chemicals you are putting in so that it can have the most pickup percentage. So I'm going to talk about textile chemistry, wet processing, dyeing, and printing, particularly in the session which is called coloration, and is the third session. If we're moving from our bedroom to the washroom, it's surrounded by textiles as well. Just a perfect example of yarn engineering is your towels, which is a combination of microfiber and fleece fabric structure. This picture the upper picture you can see here is a perfect example how we do the yarn engineering and just turn a normal yarn into a very efficient absorbing fiber. We just split the fiber 1,000 times and it makes it possible to have more surface area, which makes it possible also to absorb more water. Compared to on the right side of this image, this is the conventional fiber which has less surface area compared to microfiber. There is some other aspect of the microfiber with the sustainability, but I'm not going into that direction. If I go about the fiber innovation, just consider about the nylon, which is like transforming our textile industry since 1960s. And in your toothbrush, in most of the toothbrush, you have nylon fiber because it has high abrasion resistance, it has very high strength. Also in terms of the sustainability, the curtain we use as a shower curtain is currently going to be biodegradable with PLA. So when you're talking about all of these, you need the knowledge of fiber and fabric manufacturing. Today we are going to talk about the fiber, but the fabric manufacturing thing is going to be covered in the next lecture series. If I move from my home to the outside, I need to use transportation, either my own car or subway or metro, whatever we are going to use. We see a lot of examples of textile. Our cart seat belt, even tire, everything is composed of textiles. And particularly here in this slide, I have included all the examples of car seat, some example of car seat and car belt, because I have a personal experience. I was talking with a startup company, and they are developing a very good fabric which has a very high strength for car seat, and it's going to be, according to them, it's going to be the upper layer of the car seat. The first question I asked them, what is the abrasion resistance of the fiber they are choosing? Because I knew that the fiber is very strong, everything is good, but the abrasion resistance is very poor, brittle. So when we are developing this type of material, we need to consider the performance it's going to have. For example, abrasion resistance. What kind of test we need to consider while developing particular product? Effect of moisture. This is very unfortunate, but I see in a lot of papers, people tested their textile, which is not in a particular environment. For testing your fabric or your fiber, you need a particular room temperature and the humidity, because different fibers has different types of moisture regain. And based on that moisture regain, if I test a cotton fiber here in this room, in this temperature and humidity, and if I test a cotton fiber in another country, same cotton fiber, the country is very humid and temperature high, the properties you're gonna get is different. So to make it generalized or standard, you have to consider, we usually consider this point. And it's all about textile testing. We are going to talk about this textile testing in the fourth session and the last session of this lecture series. Moving from transportation to our infrastructure, even here, we see concrete and everything, but inside them, we have a lot of textiles example. Maybe you see during the road construction. So the important properties is the mechanical properties of the fabric we are going to use, the air permeability of this fabric, and the chemical resistance and microorganism resistance. So we're going to talk about some mechanical properties in the second lecture series. We're going to talk some of the fiber properties here and the chemical part in the third lecture. If I go to the workplace, you may identify someone who is here. So as you can see, the upper picture is mine. I have spent more than 5 years of my life working in protective fabric industry, protective fabric particularly with firefighters protective clothing. So what, through my research and also talking with a lot of people who are the end user of this type of product, we have identified a lot of issues you need to consider, but the main things came up again and again is the balance between protection and comfort. Always as a material or textile engineer, we like to have something which is very protective for you. But sometimes we forget the comfort part. So when you're developing something which is for extreme protection, we need to consider that one, and it depends on the fiber properties as well. So we are going to talk about that in this lecture. Sports and wearables. Wearables is one of the main focus of my research currently, and while we are developing this something for the sports wear, we need to really consider the fabric properties and the fiber properties. The fiber part I'm going to talk here, the fabric properties in the next session, and for the testing and the performance analysis, I'm going to talk in the fourth session. This is the last example slide to outline my lecture series is the outer space. And a lot of people I met, especially who are new and novice in this sector, are very interested in space. If I just consider this is the diagram if a person is going to a space, astronauts, what are the areas is different function it has. So if I just look at the hand, finger, and the foot, this very highest abrasion area. At the same time, you need highest flexibility. So when you are choosing fibers, you need to consider these things very carefully. If I just take an example of Canadian astronaut suit, it is composed of 16 layers of fabric. The first layer, which is close to skin, is the base layer. It's made of conventional spandex fiber, but it's also including a wearable to keep you cool. There is a circulation of water inside your body so that it can keep cool. So there is a lot of scope in this area where we can really contribute and make things more feasible and more comfortable. So here, when you are developing this type of product, we are talking about fiber and fabric, which I'm going to cover this and next session. The specific weathering, that's very important to consider, because we cannot change our clothing when we are talking about this space suit. We don't change in the morning and in the afternoon. And in this space, you can have weather as low as minus 250 degree Fahrenheit, as high as plus 250 degree Fahrenheit. So you need to choose something which can function very well in both of the temperature condition. That's why regarding the specific weather, I'm going to talk about it in the next session when I'm talking about the fiber fabric. And also for the performance analysis, I'm going to cover it in the fourth session. So before I move to the topic of today's lecture, I would like to hear if you have any questions. I know there is a question and answer session at the end of this session. We can discuss at the end of the session as well, but if anything urgent you just want to ask, we can have it now. Also, there is a Menti code who are joining online can ask their question in the Menti code as well. Okay, thank you. So I'll move on. In the next few slides, group of slides, I'm going to show some of my research which I have already published and some are ongoing. And based on this research, I'm going to talk about some fiber and yarn properties. Just to talk about my research area a little bit, what Helen was mentioning with all the numbers, if I categorize my research in 4 sectors, all the articles I have worked on the projects, 33% of my research is in the area of high performance polymer and the fiber. Sustainability is a very core part of my research. I have some personal experience with the sustainability. I take it very seriously. So as you can see here, 33% of my research is in the area of sustainability. I'm very much focused currently on the smart textiles. The work I'm doing now, some are in the review. around 25% of the work of my work is in smart textiles. As I come from a textile engineering background, I worked on bulk production manufacturing. And from my experience on working on bulk production manufacturing, I noticed some gaps, some gap of scientific articles in this area. So I worked a little bit in bulk production manufacturing. So 10% of my work is in the research area. So in next few slides, I'm going to pick some of my work, which is related with fiber and yarn, but the same strategy I'll be following in the next lecture series as well. Let's shift our focus a little bit from textiles to medical. I know we are in a hospital setting. There might be a lot of people who are very knowledgeable, so pardon my less knowledge in this area, but I've just placed two pictures here. One is the structure of muscle fiber, and another is the structure of nerve fiber. In layman's term, I'm just going to explain what is that. It's a cylindrical structure, let's consider, and inside of this cylindrical structure, we have different fibers coming out, which has sometimes different functions, but they are working with a close coordination. So we took this muscle fiber and nerve fiber structure as an inspiration, and at the top right, this is something we imagined. We thought, what about making something, developing something which might have similar structure of a muscle fiber or the nerve fiber and can have different functions in the same structure. So based on this imagination, the project called Smart Oil Revolution started. And keeping that in my mind, I started working in this project. The beginning was to trying different fiber if we can produce. And based on my background knowledge, I knew that based on the fiber cross-section structure, how it looks, and also the chemical structure, of course, how it looks, the properties of the fibers varies a lot. If I just go for cotton, we can say it dog bone shape or kidney shape. If you cut a cotton fiber, you see similar shape inside. And the way it affects your ultimate yarn or the fiber is, as it is like a dog bone shape or convoluted, it makes the cotton fiber very easy to twist when you are making a yarn. You need to twist different fibers, right? But let's consider a silk fabric. The silk fabric is very lustrous. It reflects your light very well, the room light. It's very smooth because the silk structure is friable and it reflects the light very well compared to the cotton. That's why you see the silk is very smooth and lustrous surface. In terms of synthetic, you have a lot of independence because you can change your structure, you can do whatever you want based on the manufacturing facility you have. For instance, when you talk about the wool fiber, it is very insulated. We feel very warm because it has a hollow structure that can trap the air. So considering that in my mind, that different structure can influence your fiber properties, and now you know as well. So I started preparing synthetic material, synthetic fiber. It started with nylon, because nylon, as I was mentioning at the beginning, since 1960s, nylon is playing a very important part in our textile industry. And it's very strong, abrasion resistance, and have a lot of good properties. We started with polyester as well and polycarbonate. And always when we start any research, we start from very easy step, and then we want to move. If proof of concept is working, then we move difficult to difficult. So we started with a hollow structure in the shape of circular, in the shape of triangle, in different size of outer diameter and inner diameter. As I said, we started with a very simple structure, but we imagined something difficult as well. So then we tried to do something, a maple leaf with the multi-material, not only one material, we started trying multi-material as well. But from here, we started doing some crazy structure as well. As you can see, this is a gecko, and a yarn with that shape, we tried to do that as well. So let's see what we could achieve. So for the manufacturing technique,
I'm a little bit confused between the previous slide and this slide. In the previous slide, you were talking about like how some like muscle fibers or the neurons are working together
yes.
to like do an action, right? So I'm a little bit like lost in the analogy between this and the next slide. Could you please clarify a little
Yes,
bit? Thank you.
you so much. That's an excellent question. So this is our imagination, but this is in natural form. We wanted to create something which is like a yarn and can have different sensing and actuation. So as we want to have, as you can see here, 1, 2, 3, 4, 5, 6, 7 channels we have inside. But as a thumb rule of the research, we start from the very basic and then we try to do some crazy structure. So then that's how I moved here and said that we wanted to try different structure because based on our background knowledge, we know the different cross-section structure have different properties.
So one of these will be one channel.
Yes.
And you want to put all these channels all
In one yarn. Okay, so I'm going to that slide. Maybe my ordering was not good, but I'll show that as well. Thank you so much. So as I said, we started with the very simple structure. Then we thought if we can try something difficult, and we aimed for this one as well, which is the difficult one, even the one we imagined. So the next part was how you would like to manufacture this yarn. So if I go for the basic of yarn engineering in terms of the synthetic fiber, we have 4 different types of yarn engineering. It could be wet spinning, it could be dry spinning, melt spinning, or gel spinning. Based on our scope of the work and the facility we had, we started drawing yarn with melt spinning technology. So in our lab, we built a thermal draw tower. As you can see here, in the middle, this is the furnace, which worked as a melting point. So we developed this draw tower in a way so that we can control the temperature very well, the region of the temperature, and also we have other parameters to monitor, for example, the tension we are pulling, for example, the diameter of the fiber because it affects your fiber properties a lot. And the right side image you see here, this is the real thermal draw tower we developed together. So from here, and I'm coming to that question again, and from here, how we want to prepare this structure. If I take the polymer chips, it's impossible to create different structure with the polymer chips. So we took the advantage of additive manufacturing with the 3D printing. In our lab, we had different types of 3D printing technologies. So we took the polymer chip of nylon or the filament of nylon and PETG or polycarbonate based on what you want. And we used the 3D printing technology to develop the preform, develop the structure in a cylindrical form. As you can see, then we started drawing, melting that preform to get the filament, which can be transferred to textiles manufacturing. So what we could achieve, as you can see in this picture, this is a tiny diameter fiber. We started with the hollow filament, and it is a 100 micrometer scale. We also achieved the structure with the maple leaf as well. This the right side one is a bigger one. It's 10 millimeter, not in a fiber form, but it's very coarser yarn, you can say. But the one which is a little bit blurry, it's 100 micrometer scale, so it's kind of desirable. And as I said in the first picture, we imagined for this, and we were able to draw this one as well, and it's 500 micrometer. So coming to that question again, and as I was saying, maybe my ordering was not good. That's why confusing. So as I said, the inspiration was this type of fiber. We imagined that we want to develop something like this, and we were able to produce something like this. I didn't include all the pictures or data I had because I know I have a wide audience here. But the ultimate goal was to transfer this technology, this yarn, into a textiles so that they can perform. So one of the targeted end user of this yarn was for us people who have limited capacity, for example, if I wear a coat and I need to use my button to squeeze it, but maybe I don't have that capacity. So we included it into the fabric, and I didn't have a very smart mannequin, so I took a conical flax to demonstrate this. So if you see this video, the yarn is inside, which I have just shown, and it just with the range of the electricity was 3 to 8 volt. And if it is very quick, I can play again. Is the hole, and now it's the squeezing. So it can actuate when you need it. You just switch on, it actuates, and it can button up whatever you are using. If you're using as a button up or in the cuff, it can close your cloth. Another example, how quick it is to show. The previous one was not that much. If you look at the cuff area, I'm going to switch on, and it's going to squeeze very quickly, and not that much high pressure. So this is what we could achieve with the Smart Revolution proof of concept project. And we also used, we had an industry partner in this project. So we sent our one spool to the industry partner, who was able to use that yarn in their knitting machine and produce a sample for us. So I'm shifting my focus from Smart Oil Revolution to sustainability. I like this picture a lot. Whenever I talk about the sustainability part, I try to put this picture, and I'm kind of this person as well. I have a lot of clothes in my wardrobe, but when I try to dress up, I feel like I don't have anything to wear. The easy solution, I go to a shopping mall, and the cloth is becoming cheaper and cheaper day by day. I buy another one, but in my home, it's 600 square feet. In my home, I don't have that much space to keep all the clothes. So the older clothes I used for 1 or 2 times go to garbage. And it may not going just in front of your house, but this garbage is being dumped in some other areas. And as I was saying, I have a very personal experience with sustainability and impact of textile sustainability in environment. And I always mention that we are paying here for a t-shirt maybe $10, but someone else, something else is paying the cost. And a very perfect example is the Rana Plaza disaster. Some of you may know, more than 1,000 people died in the Rana Plaza disaster. During that time, I was in that area. I had the opportunity to volunteer for this disaster event, like to rescue people, and I saw how much they suffered. And the picture in the right is not a picture, something I just took from internet. It's a real picture I took on my own mobile phone. That's why the quality is not good. But it's a picture nearby textile industries where people manufacture this type of clothing. So always environment or the people is paying the additional price, apart from the $10 we are paying. So that actually motivated me to do a lot of work in the sustainability. And when I'm talking about sustainability, I would like to give a little scope of understanding on different types of fiber. We have natural fiber. It's coming from nature, it's natural fiber. Very simple definition. We have regenerated fiber. Regenerated fiber is we are taking something from the environment, natural, and then we are manufacturing on our own capacity. And then we have synthetic fiber. I showed an example of synthetic fiber. I wanted to show this slide before moving on some research on the sustainability, because in most of the cases, I was like that as well. In most of the cases, when you think about natural fiber, we feel like it's natural fiber, so it should not do any harm. It's going to be a biodegradable. But just let's take an example of cotton fiber and some disaster event. If we just consider this Aral Sea, it has been dried up in 2010, and it started shrinking since 1973. There are a lot of reasons for this sea to dry up, but according to literature and the scientists, huge cotton cultivation in that area was one of the reasons. Why cotton cultivation and drying sea is relevant? because cotton need a lot of water. Not only about water, it needs a lot of pesticides. So therefore, we really need to look for alternative fiber sources, either natural fiber to manufacture natural fabric yarn, or natural fiber sources to manufacture regenerated fiber. With that in my mind, I had the chance to work on canola fiber. And I took this example because here we are very familiar with the canola oil, right? And the main purpose of canola is producing canola oil. But since 2015 approximately, or 2010, people started working in this area and to see how canola fiber can be used in textile manufacturing as well. And we saw some gap, although people started working. One of the thing about the canola or any kind of bast fiber is that how we are extracting the fiber from the stem or the bast. We have very good research in terms of jute, another bast fiber. We have very good research in terms of flax, another bast fiber. But as canola started getting attention, it didn't have a lot of scientific evidence how you extract the fiber. So to fill that gap, we started looking how, based on the rating behavior, we can have highest yield percentage of the fiber. So we took canola stem and immersed in just liquid water. There are different techniques of rating. You can do it in enzyme, but we took the simplest one. And then we tried to see how the water color or the solvent color really affect the extraction. Sorry. And based on this research, we have identified, we also wanted to see how the dimension of the stem or the diameter of the stem also affect the fiber yield percentage. And the paper has been published in Journal of Natural Fiber in 2021. And the finding is we identified that when the color is golden, this is the optimal time to extract the fiber. And if it is going to be greenish, this is the critical region when your fiber is going to be starting degrading. And also we identified that based on the stem size dimension, 30% of the variance happens during the yield of the fiber. Now we have done the extraction. Wanted to see some example of work. So we saw some people work on the area of textile fiber as a canola as a textile fiber, but we wanted to see if it can be used in the composite as well. There are some startup companies here in Canada as well who are working with canola fiber and composite. And why canola fiber attracted our interest as a composite material? Because of the fiber density. So when you are looking at any fiber, try to develop something protective clothing. One of the important things we need to consider is the density of the fiber. We want something for the people to make it protective, but we also want it as a comfortable one. And sometimes we miss that the density and the weight of the fiber can affect really. But moving to canola fiber, so the density really attracted us. So what we did, the paper has been published in Advanced Fiber Materials. What we did, we took the canola fiber, we combined it with different percentages, 2.5 and 5% with the wood. And we tried to see how the deflection behavior of the composite we prepared compared to the wood only. So as you can see, the green one in this picture is the 100% wood, and the right two one is purple and one is red. The purple is 2.5% canola, and the red one is 5% canola with the wood. And this has been bonded with thermosetting resin. And we have identified that if you include the canola, you can get two different behavior. One is it reduces the ductile behavior, and it's not brittle. You get a little bit of relaxation, and also the strength goes up to, when you go for 5%, the strength goes up to 100% compared to only using the wood. The another fiber, which is also getting a lot of attention currently is the lyocell fiber. And the lyocell fiber is an example of man-made regenerated fiber. The traditional sources of lyocell fiber is wood pulp, basically. Sometimes people use cotton linters as well. If I talk about other regenerated fiber, mostly wood is the primary source of this, all the regenerated fibers. So this means that although wood is a renewable resource, but there is a lot of demand on that particular product. So we thought to look for something else, and my previous group in that group started working intensively on using hemp as a resource for producing lyocell fiber. Why hemp? Especially in Canadian setting, the weather is very preferable. It's grow very fast compared to other natural sources and yield a lot of biomass per hectare. Also, if I take the example of cotton, you need a lot of water, insecticide, fertilizers. In case of hemp, you don't need that much compared to cotton. And it's, as I said, locally accessible feedstock. So the work published in 2023, and we wanted to see how hemp can be used as a textile fiber. One of the criteria when you look for textile fiber is how crystalline the fiber molecular orientation is. So we went for an XRD to see different man-made manufacturing fiber to see their crystallinity percentage. Here in this example, for instance, you see wood, hemp, viscose, and lyocell hemp as well. And we got for the hemp around more than 60% of crystallinity, which is close to the cotton. So based on this result and based on the literature survey, we understand that there is a very good scope of working in this area using hemp as a source for manufacturing lyocell fiber. Then the next part was to shift to yarn manufacturing, because with the fiber we can use in composite and other things, but we ultimately want to convert it as a fabric. So the team started looking at different lab scale system, rotary evaporator, syringe pump, or microreactor vessel. And based on this three technique, this is the picture of the first fiber. First fiber we were able to produce, and based on then we did the crystallinity XRD as well on the manufactured fiber. And as you can see, with the crystallinity value, this is not what we got in the raw fiber, right? We got around 60%, more than 60%, and here we are getting around 55%. So one of the thing differed here, the fiber you see here is going into a water bath. We are not growing the fiber. So what happens when you manufacture any fiber and growing the fiber, during the stage of growing, you get molecular alignment. And with the molecular alignment, then we get higher crystallinity. So that will be the next phase of this work, to include the drawing of the fiber. But at the initial stage, I was very happy to see this result. Okay, I did a lot of talking. Any questions so far? Also, there is a Menticoat in the front.
Hi. Okay. Hi. My question is, when you're doing research, I know that a lot of the manufacturers, like the larger manufacturers, even in Europe and in the States, they, because water is such a commodity and is used in manufacturing, so they found a way, like, you know, in stone and quartz and everything, they managed to figure out a way to recycle the water. So when you're doing your research, do you take that into consideration when you're doing the coming up with all these fibers, right? And then when you get to the manufacturing process, like how much water is required to produce, you know, one of those fibers? It's just a question.
Yeah, no, that's an excellent question, and I'm happy that you asked this question because from my experience working in the industry as well, we use a lot of water and not renewable. We can renew the water, but the barrier is the cost you have to recycle all the water is more than the cost to manufacture equipment. So as I'm coming from that background and I know the impact, I always take that into consideration how sustainably I can manufacture my prototype and how effectively I can manufacture my prototype so that it can go to the scale up stage, just not sitting into the lab. So yes, I try to take that into consideration. But thanks so much for the question.
Oh, sure. Yeah, sounds good. I was just curious when you were showing the slide about the composite material that is like a wood substrate. Um, when I see composite materials, there's often, or pretty much always, inevitably, there's like a polyester-based resin. Oops. Good thing that was empty. At some point, so I'm just curious if you've encountered any alternatives to the polyester resin when dealing with composite materials.
Oh, thanks so much. A lot of interesting question. And yes, we tried to consider because the main question is sustainability. I'm using canola fiber, then why polyester resin, right? So we started doing with some sustainable resin, but then we realized that we have too much variables. The canola fiber is one variable, then the resin is one variable. We don't know what is happening. So for that particular research, we ended up using the polyester resin just to see the canola fiber behavior. But yeah, of course, we need to. In that research, we didn't because the resin we got from off the shelf was not performing better, and then we went to the polyester. Thank you so much.
Get my steps in.
Hi, I have another question. I'm kind of curious because I know there are a lot of fabrics. Like in my work, I tend to specify because I work on commercial projects. So I'm just wondering, for fiber, eventually, if you're looking at, fire, like incorporating fire-rated fiber with it, how would you do that? Because I noticed that in one of your slides, you actually have to go through the heating process and everything, to strengthen the so in that sense, like, is your research, incorporating part of it? Because fire is a huge problem, as you can see, in the world, actually.
Yes, yes. Of course, fire is a huge problem, and also depending on which fiber we are using, right? So the example I showed you, the manufacturing the thermal rotor, that's synthetic fiber, nylon, and polyester. That's not fireproof, of course, but I had the chance to work with inherently fire resistance, like Kevlar, Aramid, right? PBI, PBO, but also fire resistance finishing as well. But the way I see the end user, maybe as a first step, we develop the fiber, but in terms of the regulation as well, I know maybe kids wear also need fire resistance proof finish as well. Maybe we have to go for fire resistance finish in the future for that particular product, maybe in the yarn scale or in the fabric scale.
The trouble is that when you, for fire rating, I know that even fire rated, right? When they wash, like even in healthcare situations, like 110 degrees centigrade or something like that, then they have to really, it gets to be very, very expensive.
Yeah.
The other question I have is also, I know that for antibacterial, there's some fabrics that have actually incorporated, copper or silver in it, for antibacterial. So my question is, in your research, ongoing, will you be looking at those aspects as well? Because that's one of the big problems in healthcare.
Yes, I'm very thankful that you are bringing that up, and also when you're using nanoparticles, right? It get released very easily depending on the temperature you're using. Of course, depending on the scope of the work I'll be doing, that are the consideration. I'm very grateful with all the background knowledge, and I'm learning from everyone else as well. I try to take that thing into consideration when I'm using anything with the nanoparticles. What is the size of the nanoparticles? Because based on that size, it also depends on how quickly it's gonna get released, how many washing cycle it's gonna have, will sustain. So yes, I try to consider based on the scope of the result. Thanks so much. Okay, so I guess we will move on and we'll keep some time for the question and answer at the end of the session as well. I have a few more slides. I'll try to wrap up very quickly. And I wanted to give an example, developing a garments, but everyday wear. Everyday wear means whatever all of us are wearing currently. So to shift in that focus and to develop everyday garments, we start from different fibers we have. We have, as I showed in previously, natural fibers. Could be cotton, flax, hemp, jute, sisal, wool. These have high comfort because they are very good moisture absorbent, from 8% to 16%. These are biodegradable. As we are talking about the sustainability, that's a very important feature. We can have regenerated fiber. The independence you can have your own structure, you can modify the properties a little bit, and that's why you see the viscose or lyocell are softer compared to cotton fiber, though they are using cotton as their regenerated source. It has good droppable properties. The dye take-up is also good. For example, for viscose, you have 11% moisture regain compared to cotton, which is 8%. Also give good strength, but it depends on how you changing the fiber chemical structure. In terms of the synthetic, you can have polyester, polyamide. We are talking about fire, so we have PBI, PBO, and for the elasticity, we have elastomer. So let's consider we would like to develop a t-shirt or regular wear, and we have these fiber choices. Which one I'm going to pick? Jute, sisal, hemp, flax. These are two cores. The diameter is very thick. The hand feeling is not soft. It's very rigid. If you take a jute fiber or hemp fiber, this very, very, very rigid. And the droppability is not good. So the droppability is important because the cloth need to get the shape of your body as well, right? It need to drop. So I'm not going to take this bast fiber as an fiber blend. Then we have wool, all the animal fibers. These are delicate in care. You have to take high consideration when you are washing or doing the laundering. The thermal insulation not needed for our everyday wear. If you are going for outside, then wool might be a very good choice. Then comes with the regenerated fiber choice we had, which is lyocell modal acetate. These are soft, eco-friendly, but if you just take for example, I'm talking about viscose a lot because I see a lot of viscose example. If you take the viscose fiber manufactured fabric, these have low abrasion resistance. You will see a lot of peeling if the finishing is not good. And also, when this fiber get wet, the strength get less. So the option we have, cotton. It's a very breathable, highly moisture absorbent, comfortable hand feel. But the problem with the cotton is that it is not that much strong enough. Compared to synthetic fiber you might have nylon, you might have polyester. It's very strong. It doesn't wrinkle compared to the cotton, because I'm going to my beginning slide. I showed different cross-sectional structure, and if you can remember, the cotton cross-section was like a kidney shape. And that's why it easily wrinkles. While you are using a polyester or nylon, that's a cylindrical shape. It doesn't wrinkle very easily. So then polyester comes as an option, and you have the quick drying as well. That's why in most of the fabric, if you check cotton fabric, it's called CVC, cheap value of cotton. So you have different percentage of cotton and polyester. And also, like if you want to have little bit flexibility with the drape and softness, you can include the viscose. But again, it's going to increase the price as well, depending on what you can. So the choice is going to be a blend of cotton, polyester, maybe or not, with the viscose. And the importance of fiber blend is also very important in terms of making fabric, which I'm going to cover in the next session, hopefully. Now we choose the fiber. What are the yarns we can take on? So always we consider about fiber, and I see most of the time we forget about what are the yarns inside. So I just take few examples of different yarn, natural fiber yarn. It could be open-ended. This is the cheapest version of natural fiber made yarn. It could be ring spun, which can have softer and stronger. But the better version is compact. So in the ring spun technology, you have another just air jet technology just that reduce the hairiness of the yarn. So if you take a compact yarn made from same fiber, if you go from compact to ring and open end, you will have less hairiness in compact, then a little bit more in ring, and then in the open end. So which one we are going to choose? The open end, as I said, it's cheaper, but it may not be the best one considering the rough surface and not comfortable. I will go for the ring spun one if I consider the price, because it's a competitive market, right? But if I know that my product gonna be for a very niche market and people value the quality, I'll go for the compact yarn with whatever the fiber blend I choose. I'll go very first with the sportswear. Whenever I talk about sportswear, the main thing we need to consider, because the sportsman usually they do a lot of activities. So I try to see that in the perspective of human ecological model. If I take an example of human ecological model, this is one of the human ecological model which inspired this work. At the core center of your product development, whatever product you are developing, for my case it's sports textile. We take the person, sex, gender, and then we consider different climate. In the microclimate, we say the space between you and your cloth. And if you go into research, I don't have the time to explain everything, but the space in the microclimate varies your comfort a lot. Especially when you are talking about the protective clothing, this is a major factor. Then we go with all the clothing properties, the properties of your fiber, the properties of your fabric, the moisture transfer, and the drying rate. Then we go with the ambient condition. In which condition? If I want to develop a textiles which is going to be used by ice hockey player, and if I'm going to develop a textile which is going to be a soccer playing in another part of the world, the fabric I'm going to choose, fiber fabric, finishing, completely different. That's why I'm not going to choose any particular fiber, because I didn't choose a particular sports, but I wanted to show you the examples of all the specially engineered fibers made for good comfort. For example, in terms of the polyester, you have different example here. I personally like Coolmax. It has, and you can get it in normal clothing as well. If you go to the shopping mall, you'll find this fiber names in the label as well. So it has different channels, and with the different channel, it helps to do the wicking faster. So you get release from your perspiration faster. I included some other example as well. For example, Octa, which is a variation of polyester as well, released by Teijin recently. It's based on their demand. I didn't see that fiber on my own yet, but it has more than 6 channels, which makes the wicking faster. You get rid of your sweating or perspiration. It doesn't remain in your body. And there are some other examples from nylon as well. So I will just keep it here so that you might, if you want, because I know the slides are available online as well. So if you want to, if you're developing something and want to see some examples, peer-reviewed examples, you can look at these fibers, and based on your demand, you can try to have choice on your own. So it's coming to the conclusion, Helen told me the hard stop should be before 12:10, so I'm on time. So coming to the conclusion, for the fiber choice, the chemical composition, morphology, and crystallinity, I tried to cover a little bit of everything. Is very important. And we should look for the comfort-related properties. As I was saying, for the wool, it might be useful for something, but it may not be good for everyday wear. The environmental impact is coming again and again in our conversation. It's very important to take into consideration. And the compatibility with the end use and the processing methods, as someone mentioned before. And here, this is an example from my own research, and the disaster can happen like this if the fiber is not the right one. The fiber which is at the top, sorry, I'm not using the laser. The fiber which is at the top is before we started using the fabric. And this fiber after washing the fabric, multiple washing. And this happened, right? And this is from a protective clothing. This type of abrasion you cannot see on visible eyes. That means when I'm wearing that protective clothing, I feel like this is still protecting me and I'm ready to go for my job. But inside something happens which point out that maybe the cloth is not protective enough anymore. And we know some of the example happened before with this type of clothing. I hope to cover some example in the next session. Then I go for yarn choice. And the top figure is for the yarn twist. I'm coming to that. What type of yarn we are using? Is it a filament yarn or it is a spun yarn? The basic in the layman's term, the filament yarn is a continuous yarn, and the spun yarn is a small length yarn and added together. What is the yarn structure? It can be 1 ply, 2 ply, 3 ply, depending on our need. What is the twist level? If it is a very low twist level, it's gonna untwist very easily. You're gonna see a lot of peeling. If it is very high twist, it goes above the break-even point like the picture here, then you have less strength. And the blend ratio. As I was mentioning in the previous slide, the blend ratio is very important, and this is one of the example from my research as well, where we identified if the blend is not correct one, if the two fiber is not compatible, it's gonna do the disaster in your prototype. With that, I would like to thank everyone again for listening to me. This QR code is, I guess, for the LinkedIn? Yes, this QR code is for my LinkedIn. If you want to get in touch, feel free to scan, and I would be happy to take any question you might have. Thank you so much.
Thank you, Seyful. Any questions in the room? Yes. So this is for online.
So I have a question, is that when you mentioned about your research, which is smallest part is the sustainability, right? You just started, right, basically. So I was wondering how it's possible to use canola, the fiber, and is it possible to bind it with the, let's say, Kevlar, which is a very strong material, in order to make it a sustainable fiber in future? Because I know that it's not started yet, but I was wondering what's the possibility actually?
Yeah, thanks so much. And talking about the sustainability, maybe I was not clear. So this was my first focus when I started my research career. So, and regarding talking about the canola fiber, it really depends on what are the end use. Because when I'm talking about the Kevlar, if I take particular this example, this is a very expensive fiber, Kevlar. And the main unique properties of it is inherently fire resistant. So I just think when I'm using a inherently fire resistant fiber, the end user gonna be exposed to fire. So if I use another fiber with that blend, which is very fire loving, that's not gonna work. So maybe we are not going to use the Kevlar for sure, but of course, there are some articles as well where they blended canola fibers, because alone canola fiber is very rough. That's why it's not that much suitable for textile yet. People are working on that. But people blended Kalana fiber with some conventional fibers, for example, like cotton. So there is a scope and a lot of scope of working in that area and make things happen. Yes. Thanks so much for the question.
Anyone else? Everyone understands everything, Saiful.
That's nice.
Okay, well, Saiful's going to be here for the networking part, so if you join us, hopefully there's some tea and coffee left, and Saiful can answer your questions if you don't want to speak in a large group. But otherwise, thank you so much, and we hope that you'll join us for the next talk that Saiful's doing, which is November the 5th, same place, no windows, sorry. And then our last two talks will be in January and February next year. So yes, hopefully you'll join us, and thank you so much for coming. Thank you.
Yes. Thanks again.